So hi everyone, I'm Matt. I'm an AWS community builder and ambassador. Like the intro says, I work at a company called CDL. Basically use data and AI to power digital insurance journeys. And this is the talk of our database migration to AWS. So I joined CDL in 2014 as an Oracle DBA. At that time, we operated from two data centers. You can see one of them here in Stockport. They cost about £4 million each to build. As you all know, customers demand really high availability for software solutions. So in addition to the two data centers, we built out a really robust database architecture running Oracle. And we had Oracle real application clusters. So if within a single data center, the database failed, it would move on to one or two additional nodes. If all the nodes in that data center failed, well, that was okay because we ran Oracle Data Guard. So we would fail over to the other data center, which had the exact same 3-node cluster setup you see here on the screen. The database software, this all ran Oracle on an Oracle Enterprise Linux. So we used something called ksplice, which allowed us to patch the operating system with minimal downtime. And we ran Oracle VM on top of Oracle hardware with CPU pinning to meet all the various licensing requirements. We had NetApp storage that gave us mirroring of our backups over dedicated links that we put in between the two data centers. And of course, we had all of this monitored, and we used Oracle Enterprise Manager, and we used an open source piece of software called Rundeck, which helped us schedule and manage all of our kind of database backups and other scripts. So, as you can hear, we were all in on Oracle. So we had a team of Oracle DBAs. We even ran our middleware for our application on Oracle WebLogic. There was a lot to look after, but it did all work, and we were really proud of the high availability we delivered to customers. However, when the licensing deal came up for renewal, the price changed, and it quickly became apparent that we needed to be able to move to another database solution and to have our software really cost optimized. So at this point, it's kind of late 2015, and we'd started looking into the cloud already with AWS specifically, and we'd already started building a brand new solution, different product on AWS. But we weren't all in on the cloud at this point, so we still saw a need for on-premise deployments. So some of our DBAs started to look at building out a PostgreSQL architecture that would work both in the cloud and on-premise. So we spent about 6 months trying to develop the on-premise architecture you can see here. So you've got Postgres running on top of VMware. We're still using NetApp for our storage. We've got something called Patroni sat in the middle, which is providing the failover between the database nodes. And this also required a distributed configuration store, so we had to set up etcd. At the time, NetApp storage didn't have a driver for Postgres for doing like database snapshots, so we had to write bespoke scripts to get all that up and running. And we did get this stack built, and then one day in the development environment, we did an upgrade on Patroni, and it failed, and we got really, really stuck, and it took us a while to bring it back. Fortunately, we didn't have customers running on this at this point. It's still kind of an R&D development type phase. But CDL as a company had announced that we were cloud first, but not yet cloud only. However, as database engineers, we took the decision not to build out a database service on premise. It was actually going to be too much work, and we hadn't actually got to work on the business problem yet. So you remember that was migration of the application from Oracle to Postgres. What we were actually working on here was all plumbing that we thought was needed for us to start working on the actual business problem. And so it's kind of easy to write all that off. Kind of on-premise work we did with Postgres as a total failure, but we don't think it was. The team at this point all had Oracle DBA job titles still, so learning Postgres from the ground up taught us a lot and really helped us later on. Moving to RDS in Amazon removed a lot of the fear of all of that kind of plumbing work that was required and the potential failures that we might need to deal with when we hit production workloads. We were still learning, but what we found is that shifted away when we went into AWS, away from infrastructure, and we started to look at things more deeply at the database level. So we started looking at things like PG Stack Statement, CloudWatch, and looking at tools like PG Badger, and more importantly, learning the differences in the dialects in SQL between Postgres and Oracle. So I'm going to talk you through the kind of migration steps that are fairly typical for database migration. So this is Oracle to Postgres. First of all, you want to point the schema conversion tool at your database, and this is going to give you a report of what you're going to need to change. I kind of think of this as like a one-time thing, as long as your application is not changing too rapidly. Out the back of this, you're going to get a set of database scripts. You can then basically create that schema in a Postgres RDS instance running in AWS. Next, you're going to want to get your data over into Postgres. So for this, use a change data capture or a CDC tool. And this transfers your table data, your primary keys over. Once you have that, you can look at all the database objects, so things like views, functions, indexes. Any database code will need to be converted to PG PL/SQL. And so PL/SQL in Oracle to PG PL/SQL in Postgres. There's no magic converter that we found to do this, so a lot of it needs to be done manually. The other thing is you may have work involved in removing Oracle-specific functions. There isn't like a one-to-one mapping of every Oracle function into Postgres. What we found is a lot of those were in the database code, but some had crept into the application code as well. We also found a Oracle feature in our business intelligence solution that had absolutely no equivalent in Postgres. So I'll talk a bit about that later on, but you could be faced with a code kind of rewrite, re-architecture problem in part as well, part of the database migration. So let's talk about getting the data over into AWS, so change data capture. So with CDC, transactions are read from the source online transaction processing database. In our case, we used a piece of software called Click Replicate. Others are available, so like Amazon Database Migration Service being the obvious one. But effectively, they all do a very similar job. They send the transactions, capture the transactions in the transaction logs, and replay those, converting the SQL into the dialect required, replaying them into the target database. So the Amazon one's pretty good. We just used Click because we already had experience with it. So having not to learn another thing made sense for us. Another really cool feature, I think anyway, for CDC is to help you move towards a more event-driven architecture as well, without taking a giant leap of re-architecting your whole application. So tools like Click Replicate in our case, CDC tools, can support multiple targets, even when using a large relational database as a source. So here you have an example of a streaming platform like Kafka. We can have things like both near instantaneous reporting and also use modern event-driven architectures that respond to events on the stream. What we found is that you can start to build out new functionality in your solution using loosely coupled software components like Lambda functions, consuming and processing events from the stream. And you can do this without changing the source application because CDC reads from the transaction logs and effectively turns those transactions into events. And building systems around an event-driven architecture like this is going to simplify horizontal scalability, and it's also going to make the systems more resilient to failure in the future. So in terms of monitoring our migrations, we use this software called Click Enterprise Manager, not only for deploying the software, but we also used it to track the migrations. So it had a REST API, and we called that REST API and send all the metrics into, as it was here, the Elastic Stack, which has moved to OpenSearch. So this is one of our kind of Kibana dashboards that we use during the migrations. So you can visualize kind of key metrics, so things like maximum latency by replication task, both current and over a period of time. You can also kind of see and gauge the overall latency. So at the time we were using Direct Connect, a mixture of VPNs and Direct Connect. So we wanted to see the overall effect on latency as we did more and more migrations. As we had multiple customers, we were running multiple migrations in parallel across that same set of network links to AWS. And general things like CPU and memory utilization shown on the dashboard here, both by server and also replication tasks. And finally, the row at the bottom, see each state of the task, whether it's good or bad. So with kind of those steps for migration defined and tested, we found that's obviously doing 600 migrations, we were going to have to repeat them a lot. So we needed to automate. So we created the change data capture tasks in the replicate console and exported that definition as JSON. And then we used that JSON as a template so we could make each database migration config driven, kind of finding and replacing the client-specific items like host name and schema name. And the automated migration process, and then just basically have an input file of variables, and our process built all the required scripts with the correct customer-specific values. At the start of each migration, what we did is lock the Oracle database accounts and then roll back if we needed to, which is the case of unlocking those Oracle database accounts and switching back the application endpoint. All of this deployed as infrastructure as code, so you're going to get some benefits from doing that. The main one for me is reducing risk. Automation removes that human element as much as possible anyway. I'm certainly not my best doing a manual deployment or a migration late at night. At some point, I'm going to make a mistake. The other thing is consistency. So we've tested in dev, we've tested maybe in a customer-facing test environment. What we put in production, we want to make sure that's consistent, and what they signed off is what they're going to get. So it's really important the automation delivers that consistency. The other thing is, particularly for us, we had a large project to migrate everything to the cloud. We needed speed of deployment. So automation allowed us to roll out changes quickly through multiple environments and for multiple customers all at the same time, and without having to scale our team. So after the initial kind of migration, kind of your databases in your kind of development environments, you'll typically start with your application, and this is what happened to us. Well, the first thing it did was fail. There was lots of kind of connection, initiation, SQL statements trying to run that we're trying to select from the dual table. This is an Oracle only thing. So what we did was we created a fake dual table in Postgres to get up and running, and then we looked at refactoring the application later on. Our second attempt, the application did start, but it was way too slow. So we had developers saying that screens that used to take 3 seconds to load now taking 2 minutes or even timing out. And what we started to look at was the SQL that was running. So we saw a horrendous number of joins in the SQL, and it also bringing back lots of unnecessary columns. At this point, we changed about 10 views that were coming up consistently as poor performers in the monitoring that we had. And then we continued with the tuning. So this is kind of some hot tips, if you like, around things to look at first when tuning as part of an Oracle to Postgres migration. The first thing is the join collapse limit parameter. What this does is it influences the query planner to rewrite specific join constructs. So a smaller value reduces the planning time, which could lead to a faster execution because it's doing less time planning. But if it doesn't have enough time to plan, you might get an inferior query plan. So there's a balance on that dial of what this needs to be set at. Because the query planner, if it doesn't have enough time, it doesn't always choose the optimal plan. advanced users often set this parameter in the database. On a similar note, the from collapse limit. So this is where your list of tables and your from clause in your SQL, basically it considers, it will start, the planner will start to kind of merge subqueries into other queries if the resulting from list and will have no more than the value specified in this parameter. Again, a smaller value will improve the query planning time, but could give you inferior query plans. The next thing is work mem. So this sets the maximum base amount of memory to be used for a query operation. So things like a sort or a join, before the database has to write out to temporary disk files. So the default at the time we did our migrations was 4 megabytes. This was way too small for us. Note that for like complex queries, you're going to get several sort or hash operations often running in parallel, and each of those operations is going to be allowed to use as much memory as specified in this parameter. And the next thing we did was PG stat statements. So this is a Postgres module which provides you with a means of tracking, planning, and execution statistics for all the SQL statements that are run on the server. So we basically load this to start up automatically. So if you're open source with Postgres, you might be familiar with the Postgres conf file. In RDS, that's an operating system file, it's not available to you. So you change those entries in those configuration files through parameter groups in RDS. Basically, by loading this at database startup, statistics are gathered by the module and made available in a view with the same name, and it contains a row for each distinct combination: database ID, user ID, query ID. The other thing is pre-warm. So this module basically allows you to pre-warm data into the buffer caches in the database. So really good for loading like kind of local tables, things like that. Again, we used shared preload libraries to basically auto pre-warm the database startup. The next thing, logging. So we turn logging on for any statement that is taking more than about a second to run, and we send all those logs to OpenSearch. In the tuning kind of stage, through identifying these long-running pieces of SQL, we ended up changing about 60 views overall, one by one, adding them to development databases and then testing them out properly before putting them into the kind of production code base. We actually still have the dashboard tracking these long-running pieces of SQL running in production today and in all the environments. So the idea is it's a proactive measure now. So if we get rubbish SQL, hopefully you see that in a non-production environment before it starts to affect customers. Tooling, we tried out loads of tools. So having Postgres logs shipped to CloudWatch logs, having Amazon RDS Performance Insight, this is a database performance tuning and monitoring feature that helps you quickly assess the load on your database. We use PG Badger, this is a Postgres log analysis report tool. However, what happened kind of organizationally was more interesting to me anyway. So the DBAs now all switched over to using Amazon RDS. Because of that, they're not installing database software. So they've got more time to work directly with the development teams on making the actual software better. What we suddenly found we were doing almost by accident was DevOps. DBAs sat next to developers working together and not raising tickets anymore to pass messages between each other. So kind of touched there on the DBAs not installing database software, and RDS is also handling your patching and your backups. So that kind of raises the question of, well, what do DBAs do now? Well, for us anyway, the answer is automation on top of the automation. So here's some stuff that they do. They build and maintain Terraform for our infrastructure as code. They build and maintain pipelines. They use GitLab, and they can roll out changes to new environments through config. They're also able to move the database technology on way faster than they did before. So we take a look back at our Oracle 11G to 12C upgrade on premise. That took us over a year just to do that software upgrade. Now that we have RDS and automation, we can move between major versions of Postgres in 4 weeks. We're actually throttling this ourselves. We could do them all in one night if we really wanted to. We can roll out to new clients much faster. We can roll out critical bug fixes faster. We can also effectively go as fast as the business wants. The tech isn't a bottleneck anymore. What we're actually finding is risk appetite either from the company or customers on how fast they want to go. So the DBAs think about CDLs and company growing. What happens when we go from 600 databases to 1,000 databases, 2,000 databases? Well, that's okay because with all of our automation, they can scale to deliver that company strategy. This automation doesn't just happen, but when you're not having to do, I guess, feeding and watering tasks like installing database software and creating backup scripts and things like that, you've got more time to add value in other places. The other thing that automation has done has improved the developer experience at CDM. So the DBAs have built an enhanced self-service piece of functionality, which is built using a tool called Rundeck. So what we find is like developers will often require clones of production databases, maybe to work through potential bugs or want to test the production volumes. So through the self-service portal, developers can create their own database clones. There's an automated process that uses point-in-time recovery of a production database. It puts that to a new RDS instance. Then it does things like downsize the instance class, maybe makes it single AZ just to save on those AWS costs a little bit. There's a kind of automated masking process that's run to protect sensitive data. And then finally, a set of temporary credentials that provide to the developer. So we used to have something similar on premise for like large clients, and that process used to take about 18 hours to clone a database. The DBAs have optimized this now by creating and masking clones of production databases every weekend, and then through using RDS snapshots, we can make those available for non-production AWS accounts. So now a self-service request typically takes around 18 minutes, and an 8 terabyte database is available to a developer within 30 minutes. And kind of in the event of a customer facing an incident, then you can, the DBAs would often get asked to run like a health check on the databases. So that's effectively now been triaged and made available to like our operations center, so they can run all those checks automatically on the back of an incident without having to wait for a DBA to finish. And also customer testing has been improved by using the same cloning from production mechanisms. DBAs are no longer needed to export and import data. So effectively, the database at CDL has become a product. We're using RDS as our base, but then our DBAs are adding value on top of what RDS gives for our specific needs. So a couple of kind of AWS programs to mention. The first is RDS Ready. So this is, if you're an AWS partner, you can go for the RDS Ready competency. So this really helps customers that are integrating with AWS services spend less time evaluating tools and more time scaling use of products. So CDL has done the RDS Ready twice now. So we were launch partners at one of the re-events a few years ago. And basically, it's a set of best practices that you have to demonstrate your products follow to meet AWS architecture, security, reliability best practices. A few things that RDS Ready focuses on. One is connection pooling. So if it likes an application frequently opens and closes many short-lived applications, then it should use connection pooling. So there's kind of some examples here of what we've got our connection pooling sizes set at for our Java enterprise application. There's a load of like requirements around like security, so things like database credentials not being stored in plain text. So we use systems manager parameters store with secure strings. Could use secrets manager as well to meet that requirement. Obviously, database encryption. I can't think of an application now where encryption isn't a requirement. But basically, one of the things you've got to show for RDS ready is not only encryption at rest, but encryption at transit. So there's a RDS force SSL parameter, which we set to 1, which basically forces all of the database connections to have encryption on in flight. You've also got to demonstrate that you cover database failure and performance scenarios to get the RDS ready badge. So basically, when we test our performance, we use something called Gatling. We're an insurtech, so our biggest workload is car insurance quotes coming in. So we run that car insurance quote simulator for about 30 minutes. 10-minute mark, we basically force a switchover of the RDS instance and see what happens. So make sure that the Route 53 entries have got a low TTL value set, and that the application can carry on in the event of a database failover. And you've got to show evidence that that all works correctly, and the application can start back up again when it's failed over to a new instance. I mentioned earlier on about business intelligence software having a feature, an Oracle feature that wasn't in Postgres. So this is fast refresh materialized views. So our BI solution takes about 700 database tables that have been optimized for online transaction processes and then denormalizes them for analytics workloads. Because that feature didn't exist, we had to work with the AWS database freedom team to basically create fast refresh materialized views in Postgres. And there's a QR code there for a database blog and links to the open source code if anybody's interested in that. Skip these demos. I'm running out of time. So a final kind of tip to close. So I think anyway, AWS gives some really awesome building blocks. But for our migration to succeed at scale, we needed the help of many teams of engineers, of course, to do all the things that I spoke about here today. But we also had involvement like legal, compliance, project management, service management, and also our customer teams to make sure that our flagship product was ready to be cloud only. We recognized every migration by hanging the cloud at our campus in Stockport. And when the last migration was completed, we ran a cloud celebration day. With 200 people coming to campus for food, drinks, and a bit of fun. We recognized key individuals, but everybody at CDL on completion of the cloud migration project was given an extra day's holiday. So on an unrelated note, I also run deep racer events at our campus at CDL, and I brought the track with me here to Belfast in the back of my car. So do come say hello and check out the racing. Thanks very much for listening.